Hi everyone. In this presentation, I will talk about ghost, but of course not a real ghost like this one. Ghost RAT is one of the popular rats used by many threat actors, especially Chinese-speaking threat actors. Ghost RAT has a history about 16 years, and this is not a new malware, and maybe that ain't fancy for some people, but please don't jump the gun. Ghost RAT has still been used by many threat actors, and variants of Ghost RAT have been developed. So we believe that Ghost RAT is still an interesting research target. And as this title says, I will talk about two interesting Ghost RAT samples that were used in the past attacks and reappeared this year again. Especially, I will do deep dive into a Ghost RAT sample we are calling Chimera Ghost. And after that, I will share our approach to attribution and hunting to become Ghostbusters in 2024. And in fact, I had no choice but to remove over 20 slides and one video to finish this presentation in time. And, but I appreciate VB team for giving me the opportunity to write a paper. And please refer to the paper that I cannot talk in this presentation. And just one more note. Indicators and script I wrote to decrypt encrypted Ghost RAT and decrypt encrypted strings, all uploaded to the GitHub repository, so you can also check them later. And before going to main topic, please let me introduce myself quickly. My name is Hiroshi Takeuchi. I'm a security researcher at MACNICA. That is a security service provider in APAC and the Middle East. And my main responsibilities are reverse engineering and incident response. And my main research topics is on cyber espionage, TTPs, and my recent researches are, one is a flow cloud. That is one of the tool set used by TA410. And another one is attack surfaces exploited by many cyber espionage groups. Okay, this is the agenda of this presentation. First, I will recap history and application design of Ghost RAT. So, history. Now we go back to 2008. In 2008, Ghost RAT was developed CRAF's security team, who were Chinese-speaking people, and they made its source code to public available, so it means open source. And Ghost RAT is a typical client and C2 server frameworks. The compromised host initiates communication to a C2 server. Contrary to its long usage, the released version of the original Ghost RAT was all released in just 1 year, in 2008, beta 2.5 and beta 3.6, and 1.0 alpha. And the most used release version is beta 3.6. I think this is the latest version, whose source code is public available. And 1.0 alpha, according to Intel 471 researchers, they presented at BotConf 2023. They said that 1.0 alpha, its source code is only shared among closed community. So we have not been able to find the source code of 1.0 alpha, but we can get the 1.0 alpha binary, C to be the binary from the bias total. So we could analyze 1.0 alpha in the binary level. And the next is the design of Gh0st RAT. Gh0st RAT is written in C++, and its source code is a Microsoft Visual Studio solution, and that has 3 projects. One is a SVC host. This is for Gh0st RAT with the kernel driver that removes the hooks in a system service descriptor table. And the second one is install. This is for installer of Gh0st RAT. And the last one is a Ghost. This is for C2 control panel. And actually, the architecture of Gh0st RAT is not so complicated. So understanding a few key classes, in this slide, the yellow classes, is sufficient to understand the Gh0st RAT. One of the key classes is a C buffer. C buffer is used for managing dynamically allocated memory buffers. And the next one is a C client socket. This is used for communicating with the C2 server. And the C manager is kind of a core class. And this is a base class for remote control manager class. Remote control manager class implement its own remote control features, like C audio manager implements audio recording, and the C file manager implements file manipulation. So these remote control manager classes derives from C managers and overrides in a virtual on-receive function. So each remote manager class implements its own features in on-receive function. And the C manager and the C client socket, its relation is a one-to-one. So it means that each C manager object has a C client socket object and know each other via pointer address. And one thing I want to mention here is a packet flag. Gh0st RAT generally sets unique values or string in the first few bytes of packet. And the Gh0st RAT beta 3.6, as its name suggests, uses a ghost string, Gh0st string, as a packet flag. And packet flag can serve a characteristic to identify Gh0st RAT variants. I will discuss this later further. So now we understand that why many threat actors love Gh0st RAT. That is because simple and clear structure and very easy to customize. So if we want to add a new remote control feature, just add a new remote control manager class that derives from a C manager base class and implement its own features in a virtual function, on receive function. Well, actually, we have observed some developers of Gh0st RAT variants just implement its own features on the C kernel manager on receive function. I forgot to mention one thing about the C kernel manager. C kernel manager is also a derived class from a C manager, and its role is a kind of an orchestrator. It receives the receiving data from the C2 server and passes it and distributes the receiving data to corresponding C remote control manager classes. And yeah, just implementing the code on receive function of C kernel manager, it's also that can be one of the options to implement a new feature, and that just it's up to the developers. So from here, I will share two interesting Gh0st RAT samples we analyzed this year. One is a ghost of Higaisa. Higaisa is an espionage group considered to be nexus to the Korean peninsula. We found that the Gh0st RAT plugin loader was uploaded to VirusTotal March this year. Its file name is a duser DLL. Unfortunately, we cannot be sure the meaning. And we confirmed that this uploaded Gh0st RAT plugin loader is an updated version of Gh0st RAT used by Higaisa based on the code similarities. And the Tencent and the Positive Technology reports describe this Gh0st RAT in detail. And the first similarity we found is that the packet flag value calculation. Both Gh0st RAT generate a random value using getTickCount API, and both Gh0st RAT uses this generated random value as a packet flag. We feel that this is a kind of unique implementation because we have never seen this implementation in other Gh0st RAT variants. And the second similarity is code around data compression. Communication data with the C2 server is compressed by LZO algorithm. And before that, data is encrypted by the customer C4 in a duser DL that we found this year. And Gh0st RAT used by Higaisa is just using the simple byte XOR. So there is a difference in encryption, but around the code, almost same as these screenshots shows. And the same change from single byte XOR to customer C4 is also applied to the configuration encryption. So we saw that Higaisa seems to continue to use Gh0st RAT variant. And second sample I introduced is Chimera Ghost. The reason why we name this Gh0st RAT variant Chimera Ghost, I will talk in later slide. And in February and March this year, we observed a malicious batch file was delivered via spear-phishing email in China. And actually, the email sender had some business exchanged emails before with the recipient. So the recipient executed batch file without much doubt. And we found that this batch file was also delivered via DingTalk. This is a popular instant messaging application in Chinese-speaking region. And we believe that main target of this attack campaign was Chinese-speaking people. One of the reasons is that Gh0st RAT and downloaded payloads does nothing and just exit if WeChat, another popular instant messaging application, is not installed on the device. And this is an infection chain to deploy Chimera Ghost in memory. First delivered batch file disables Windows firewall. That is because subsequent all payloads are downloaded by FTP protocol using FTP account credential that's written in a batch file and embedded in the downloaded payloads. And due to time constraint, I cannot explain all the details, and I will focus on fourth payload and the final payload, Chimera Ghost. Fourth payload is actually an installer, and it contains multiple DL files and encrypted Gh0st RAT files and so on. And its file size is about 1.5 megabyte. And the installer drops a legitimate exe and Gh0st RAT encrypted file and downloads the DL file by FTP protocol. And Chimera Ghost is launched by a very popular technique, DL side loading, and exe and encrypted file were dropped by the installer, and the DL file, yellow one, was downloaded from the FTP external server. And the decryption algorithm for Gh0st RAT encryption file is XOR operation using 3 single byte XOR keys. And the decryption algorithm of configuration and strings in the binary is base 64 plus 1 byte subtraction and XOR operation. And Gh0st RAT itself is very interesting for us. And another interesting payload was a real XML2 DLL. We identified that this DLL file is actually a black DLL. That is a malicious loader that was often observed around 2016. Based on the same code, same control flow obfuscation is used, and same decryption algorithm is used in both DL loaders. And another interesting thing is this loader is flagged as a backdoor Gh0st by some security vendors. Gh0st is actually a HTTP bot backdoor malware used by APT10 in around 2016. And our attribution conclusion is that actually we cannot attribute this attack campaign to APT10 because we cannot find a strong connection between black DLL and Gh0st backdoor. And we feel that this attack campaign was a kind of opportunistic because batch file was delivered to probably many people via email and didn't talk. And with our research partner corporation, and now we believe that black DL is probably a shared tool among Chinese-speaking threat actors. And this table shows the remote control manager classes implemented in Chimera Ghost. C audio manager and C video managers were deleted from original Gh0st RAT. And some new classes, red ones, are added in Chimera Ghost. And the configuration is also interesting for us. The format of configuration of Chimera Ghost is a key value format. And the configuration is embedded in a resource section. And the C2 information is, of course, included in a configuration. And the another interesting one was TXJM. This is actually packet flag values used for C2 communication. So it means that threat actor or user of a Chimera Ghost can use the values they like as a packet flag. This implementation is also we have never seen in other Gh0st RAT variants. And finally, I explain the reason why we call this Gh0st RAT to Chimera Ghost. That is because this Gh0st RAT, Chimera Ghost, shares some codes with other malwares. For example, black DLL, this shares control flow obfuscation and string encryption with Chimera Ghost. And LViewer, this is actually open source that is developed based on Gh0st RAT, shares the same class, C-sysinfo, and CZX port map with a Chimera Ghost. And Fatal RAT. This is one of the popular Gh0st RAT variant used for cybercrime. And we have observed that Fatal RAT has still been delivered via fake installer. And Fatal RAT and Chimera Ghost share the code to manipulate browser store data like Firefox and Chrome. And Nitro, this is a DDoS bot malware, and Nitro and Chimera Ghost shares the HTTP DDoS code. And for our first analysis, we used the black DL decryption algorithm to find new samples. And we could find that interesting sample called net is X. Net is X is actually one of the Gh0st RAT variant, and we could confirm that net is X and the chimera ghost, they are actually the same, almost same cause. So now we believe that net is X is the ancestor of chimera ghost. And our first analysis could reveal that the ancestor of a net is X. We could find some net is X sample that have a PDB string path. That is this one. So we could understand that net is X was developed based on StarRat 3.1. StarRat is actually another Gh0st RAT variant, and fortunately, its source code is public available. And we could compare StarRat source code with the chimera ghost binary. And we could confirm that chimera ghost, in fact, is an updated version of StarRat. And StarRat shares some codes both with beta 3.6 and 1.0 alpha, as this table shows. So our current understanding is that StarRat is developed based on the intermediate release version between beta 3.6 and 1.0 alpha. And now we know that chimera ghost is not the latest developed Gh0st RAT variant, but has a kind of a long history, and the ancestor is a StarRat found around 2013. And after that, I want to share our approach to help our attribution and hunting. First one is attribution. So Gh0st RAT is open source, so of course it makes us more challenging to attribution just only by the Gh0st RAT binary. But through our analysis for some Gh0st RAT variants, we hypothesize that areas of changes, customization, are common among some Gh0st RAT variants. So classification of Gh0st RAT based on the area of changes can help corroborating attribution. That is our theory, and the features, areas of change, we focused on feature and packet flag C2 encryption and new classes. From feature perspective, we can divide Gh0st RAT variant into two groups. One is a full featured, and the another one is a loader, downloads modules from the external server. And from a packet flag perspective, we can divide Gh0st RAT variant into two groups, fixed. This group of Gh0st RAT uses a fixed value as a packet flag, and the another group is a variable. This group uses a random value as a packet flag. And the last one is a new classes. So of course, a new classes implemented by threat actor is also can be helpful for classification. And if we are lucky, we can find runtime type information in the binary. And with that, we can identify new classes very easily. If not, we can also use code pattern matching approach like Yara rule and MACNICA. That is an open source tool introduced in Virus Britain last year. So this is one use case for the classification. Chimera ghost versus fatal rat. Both cyber criminal group have a common target, Chinese-speaking people. So we have just one question. this is the same group. And this table shows the differences from the classification perspective. And in the packet flag, both Gh0st RAT uses a fixed value, but the style is kind of different. One uses a configuration, and one is the embedded value in the binary. And the nucleus is kind of different. And traffic encryption is also different. And other factor is for Chimera Ghost, BlackDL is used, and for Fatal RAT, we have not able to find malicious loader for that. So consideration with the classification, we cannot confirm that these groups are same group. And I will talk about the hunting tips for Ghost. One is how we can hunt Gh0st RAT on the host level. We found that some Gh0st RAT variants still use the original code from the Gh0st RAT beta 3.6 or something. And especially, some variants use a my create thread function and the C client socket connect function. It remains same from the original Gh0st RAT. So writing a signature to catch these functions code can be helpful to hunt Gh0st RAT variants in memory. And the next one is how we can hunt Gh0st RAT on the network. And understanding packet flag implementation can be a key for hunting Gh0st RAT in the network. So packet flag implementation depends on the Gh0st RAT variant, but once we could identify packet flag implementation and the packet data structure, of course, we can write a signature to hunt malicious traffic or Gh0st RAT variant. And this screenshot shows of the packet data structure of Chimera Ghost. And this is takeaways from our research. So as we have seen, the Gh0st RAT, its design and a feature-rich remote control implemented in default, and many threat actors misuse Gh0st RAT variants. And we have observed the Gh0st RAT variants that were used in the past resurrected again this year. So to fight the Gh0st RAT variants, I introduced a classification approach for helping attribution and hunting approach on the host and the network level. And I hope that this kind of approach can be helpful to hunt Ghost. This is last slide, but not least, I want to say thank you to PwC Global Threat Intelligence team, especially team lead to Chris. Without their support, we wouldn't have been able to achieve these research results. So that's all for my presentation. And as I mentioned, I uploaded indicators and script to the GitHub repository of that URL. And after the conference, you can contact me if you have any question at this SNS account. Thank you.